All right. You know what I've said for 20-something years? All right, it's time to go to work in here now. You guys are a little different than my normal students, though, so I'll give you a break. I was really, really strict with my classes, but I won't be strict on y'all. All right. What we're going to do is we're going to see at the beginning of a video. This is a really good video, and you might want to write this down because if you have any kids that are going off to the universities for the first time, especially that first year when they're probably going to take a biology class, they need to watch this video because it is really good video, okay? It's very interesting, and it prepares them for that. Okay? It's really good. So it's called A Question of Origins. I think I might have that on that sheet that I passed out to you as well, but it's really good. Okay, so what we're going to do now is we're going to watch the beginning of this video is basically showing you what the theory of evolutionists believe. What is their theory? Okay, this is their theory. Okay, and so we're going to run this video, and you're not watching creation. This is the first part, is the evolutionist story about what happened long, long ago and far, far away. Okay?
In the beginning, there was nothing. A vacuum, void, empty space. And in this empty space, there emerged a primordial fireball. Billions of years ago, this fireball exploded. This explosion generated all space, energy, matter. The universe expanded rapidly, producing electrons, neutrinos, photons, and quarks. Soon, this energy began interacting, forming protons and neutrons. Matter continued colliding and interacting. Over time, the first simple elements formed. These elements also collided as the primordial soup continued to expand. Cosmic and particulate evolution continued, and stars began to group, forming into the earliest galaxies. And then, just 5 billion years ago, something wondrous occurred. Within a cloud of gas in a spiral arm of the Milky Way galaxy, our sun formed. This new star gave birth to planets, moons, and asteroids. One of these planets, known as Earth, developed an atmosphere. Earth's environment, believed to be filled with volcanic eruptions, lightning, turbulent weather, mixed atoms and energy to create the first simple living cells. Then, through millions of years of mutations and natural selection, algae, jellyfish, and flatworms appeared. As evolution continued, fish appeared in the seas on planet Earth. Some of these fish developed into amphibians, and through natural selection changed into reptiles. A segment of these reptiles evolved into a variety of creatures, including mammals. Some of these mammals became primates, and then, just 600,000 years ago, an isolated group of these primates evolved into man's earliest ancestors. This is our amazing evolutionary heritage, and evolution continues today as we evolve to our even higher destiny in the universe.
question of origins. How did the universe and all things that we see here on this planet come into being? Why do we exist? Hi, I'm Roger Oakland. Most of us have pondered these questions. And when it comes to the subject of origins, there are basically two views, the evolution theory and the creation theory. During the 20th century, the world was led to believe that evolution brought about all things. Our universe, the Earth, and all life came into existence as a result of an explosion of matter in billions of years of time. However, there are others who believe the observable evidence points towards a creator. So how can we know? What does the observable evidence indicate?
Okay. I just want to talk a little bit, and we're going to go back and forth with the videos, because I would think you'd much rather watch a really cool video than listen to me talk. And so we're going to go back and forth. Let's talk about science just a little bit. I'm going to go over, review a little bit, some things. You know, there's a lot of things involved here, but what is science supposed to be? What is science, okay? Well, like I said, I taught high school science for 21 years. I taught AP biology. I taught chemistry. I taught physical science. I taught anatomy and physiology. I taught earth science. So I taught a lot of sciences. And I'm looking in the book, and they're always saying the first thing, all the books say this, the first thing that science should do is observe. It's observations. Direct observations. It's what it's supposed to be. Science is supposed to be direct observations, okay? So a science will look, and they'll observe, and they'll write down what they see and record the information. They'll make measurements. They do all this. This is good science. And eventually they'll study, and eventually they'll say, okay, I'm gonna make a statement of what I believe is going on here. I'm gonna make a hypothesis. Okay, so science starts with observations, and then eventually you get to a hypothesis. A hypothesis is simply an educated guess. Okay? And so you make a hypothesis about what's going on. And then you say, okay, if my hypothesis is correct, then if I do this, then this should occur. Okay? So I'm trying to verify what I'm saying is what's going on right here. Then and you need to isolate all the variables down, where you basically have a control group, an experimental group. You try to narrow it down as close as you can. You're just measuring just one thing here. Okay? And then you run the experiment. And then if it turns out, okay, what you predicted would be true, it turned out, then all you can say is, you can't say, well, I proved it. No, that's not the way it works. All you can say is, my hypothesis was supported by my experiment. That's really all you can say. And then you keep checking, and then eventually you present that to the scientific journals, and then some other scientist will read it, and he'll take it, and he'll do the experiment. Okay, do you see something funny about here? Okay, is that the way origin science works? Have they observed the origin of anything? Huh? What's the deal here? How come their science isn't like? There's two kinds of sciences, by the way. There's operational science and there's origin science. Okay, and the operational science is good. I believe that's what God gave us to do. He told us that it's our job to subdue this creation, find out how it works, use it for our good to bless people. Okay, so videos and automobiles and airplanes and all this good stuff that we have, spaceships and all that, that's all operational science. It's all based on many, many, many thousands and thousands of hours studying, experimenting, hypothesis, and going on. So they gain more information, pretty soon they'll put it together, and they can do something pretty neat out of what they've learned, okay? So y'all see the difference here? You don't hear scientists ever talk about how the origin science just doesn't fit, because no one's observed the origin of anything. Because guess what? It happened long, long ago and far, far away. Okay? So to me, that kind of science, in a way, is not really science. The only thing you could do now is, okay, now, we can't really do the same kind of science, but what we could, they should allow other explanations, and they don't. Remember, the philosophy of science is naturalism. Okay, naturalism basically tells us that all that exists is matter and energy. That's it. Nothing else. There's no God, there's no creator, there's no designer, there's no demons, there's no spirit. You know, it wasn't the spiritual world that brought about the natural world. The natural world just came about by time and chance. Okay, so that's their philosophy. So they start with that philosophy, and there's only one explanation that's allowed. Okay, and that's the spirit. That's the theory of evolution, and that's pretty sad. That's not really the way. You should be able to question things. You should always be able to question. When science just gets to the point where you can't question something, then it's not really science anymore. You know, it's just a myth or a fairy tale. And that's what's happened. Because evolutionary science is very philosophical. It's very philosophical. It basically tells us where we come from, where we're at, and where we're going. So you see what I'm saying? So they like that. You know, when they die, and people like to believe in the theory of evolution, they don't want to believe in a God. So, you know, they think when they die, that's it. Okay? So anyway, all right. What we're going to do is we're going to see another video here, and the name of this video is From God to Science. And we're going to get back to this question of origins as well, so we're not through with that one yet. Okay, this guy was an atheist for years and years and years. And his family were atheists. His family belonged to the Nazi Party. I mean, he was a big-time atheist. And he gives us a story about when he went to college and he started doing science and he started seeing how complex the cell is. How many of you have ever read about how complex the cell is? Anybody in here? All right, good. To me, if the scientists should just admit, okay, the cell is staggeringly complex. If we just do the math, it ain't going to happen. So we just need to give it up. But they're not willing to do that because what? There's only one explanation allowed, and that's the theory of evolution. So even if all the evidence points towards creation, they can't go there because that's not allowed. Just like the philosophy. The philosophy trumps all the evidence. It's strange to do that. Okay, so we're going to listen to this guy. His name is Cy Gart, and he's going to give us testimony. And then once his testimony is over, we're going to watch some videos of the animation of cells, okay, and what's going on inside a cell.
Hey guys, welcome to Capturing Christianity. I am Cameron Bertuzzi, and I am here today with Dr. Cy Gart. Welcome to the show. You've been on the channel before, but
I have.
Yeah, so here you're today with us in person, and I'm so excited to meet you. Wish I could see your wife, but I'm sure that she's here. She's here in spirit, isn't she?
I miss her too.
Yeah.
Yeah.
Well, so today we're talking about your journey from atheism all the way to Christianity, and there's a whole lot that's happened in between. You know, back when you were an atheist and now that you're a Christian. We'll talk about all the steps that kind of led there, some of the science because your background is in, what is it, biochemistry. And so your background as a scientist, but that's actually what led you to embrace God's existence and then eventually to become a Christian.
Right.
So let's start at the very beginning. Tell me about your upbringing. I know we've talked about this on the channel before, but let's kind of go through it a little bit more in some more detail.
Sure. Well, yeah, I won't go into too much because, as you said, we have covered it, and it's in my book, so people can find it. But I grew up in a family 3 generations of atheists. They were not only atheists; they were very left wing. My parents were members of the American Communist Party in the 1930s, which is rare, and so. Their atheism was very strong, very militant, and that's what I grew up with. I assumed that there could not be any such thing as God, or it's not possible for there to be a God. Totally materialistic. My father was a chemist, scientist, so that was the worldview I grew up in. And also the same worldview I had when I went to college, where I started studying chemistry. Chip off the old block. And, when you're a chemistry major, you also have to learn some physics. So I was learning things about quantum mechanics and things in physics that seemed a little strange to me, but I didn't really worry about it too much. And then eventually I decided I really wanted to study life. And rather than be a biologist, I wanted to study the chemistry of life. So I went into biochemistry, where I got my PhD. And what happened was that even in college, as a young man, I began to feel there was something missing in my life. And I later realized it was some sense of spirituality, which I think is very important for all people. But I found that, whatever that you want to call that, in science at first. I was thinking, well, you know, the science is great because it gives you a real sense of purpose, a real sense of doing something good in the world, and it's true, you know, so it's great. But there was one catch, which was that what I was learning in science didn't jive with the materialistic worldview. And I couldn't have said it that way. I just felt it. For example, in graduate school, I learned about the process by which proteins are made in cells. And that's a very complex process that involves a tremendous amount of biomolecules interacting with each other, and the complexity is just incredible. And I remember feeling like a chill going down my spine. It was like, this is amazing. How did this get here? And it was something that I couldn't answer. Later, of course, like most biologists, I just came up with the answer, which is evolution. Evolution does everything. But when at that time, I kind of left things as it was and as they were, and I just started wondering about really whether science was really the only way to find any truth. And pretty soon I rejected that, as many people have. I was not yet ready to believe in God, and that took a lot of other steps. It required me to kind of break down my resistance to the idea, which I was born with. And it's kind of hard to, you know, reject all of that. But eventually I did. And then...
were there any external factors that were helping to open you up
Yes,
to God?
Absolutely. I was brought to a church by a friend.
And this was still when you were an atheist?
Oh, yeah. And I was, well, maybe by then I was a little agnostic.
Okay.
You know, I wasn't really sure.
So you got to the point of agnostic
Yeah.
all on your own?
That was all on my own, and that was due to the science I was learning. Because the science I was learning did not support a strict atheism. It did not support strict materialism.
Okay.
Okay. Am I on? Oh, okay. Jesus said to us, go into all the world and be witnesses. So we're supposed to be a witness, okay? Atheists need to be witnessed to, just like everybody else. God loves them as much as he loves us, okay? And he's sad that they believe what they believe, okay? I believe this course, if you understand the things that we're teaching here, it would be really easy for you to just at least get an atheist to question his paradigm very quickly, because the theory of evolution violates the laws of science, it violates the law of chemistry, it violates the laws of entropy, you know, cause and effect, the laws of probability, you name it, it just goes on and on and on. And the atheist has probably never heard this, and all they've ever heard is the theory of evolution. So we're called to be witnesses of atheists. And so, but anyway, getting back to the video. Okay, what we're going to do now is we're going to go to watch an animation. It's called a cell animation of what's going on inside the cell. The first part of it is the replication of DNA. Okay, and the second part of it is basically when the cell divides, the chromosomes attach in the middle of the cell and the microtubules, and they move across to the other side of the cell, and eventually you have two cells. Okay, this is an animation, okay? Cells, molecules, DNA, very, 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 very tiny. They can't go take something and go in the cell and take a video of what's going on inside the cell. They just have to take one slide, one picture at a time, and eventually, after years of studying, they start figuring out what's going on in the cell. So they've been doing this for a long time. They're probably not even close to really knowing, understanding what's going on in the cell. That's just my opinion, okay? But I always tell my students, and this is true for sure, scientists never know how much they don't know. They don't know that. There's so much that they may not know, but they may think they know 80%, and in reality, they may just know 10%, but they don't know that, okay? And they kind of overestimate. But this is a really good, watch this. This is just an animation. There are probably thousands, if not millions of things going on in this animation of the replication of DNA. So this is very simple, but if you look at it, it looks like a very, very complex machine working here, okay? All right, Cynthia.
To soak up the oxygen in your lungs and then carry it to other parts of the body. I was very much inspired by this image many years ago, and I wondered whether we could use computer graphics to represent the molecular world. What would it look like? And that's how I really began. So let's begin. This is DNA in its classic double helix form, and it's from X-ray crystallography.
By the way, this guy professes to be an evolutionist.
Find the double helix and unzip the two strands, you see these things that look like teeth. Those are the letters of genetic code, the 25,000 genes you've got written in your DNA. This is what they typically talk about, the genetic code. This is what they're talking about. But I want to talk about a different aspect of DNA science, and that is the physical nature of DNA. And it's these two strands that run in opposite directions for reasons I can't go into right now, but they physically run in opposite directions, which creates a number of complications for your living cells, as you're about to see, most particularly when DNA is being copied. And so what I'm about to show you is an accurate representation of the actual DNA replication machine that's occurring right now inside your body, at least 2002 biology. So DNA is entering the production line from the left-hand side, and it hits this collection, this miniature biochemical machines that are pulling apart the DNA strand and making an exact copy. So DNA comes in and hits this blue donut-shaped structure, and it's ripped apart into...
by time and chance, okay? That's what you have to remember when you see this stuff. It just somehow it all came about by time and chance. It's my joke.
Two strands. One strand can be copied directly, and it can be seen spooling off down to the bottom there. But things aren't so simple for the other strand because it must be copied backwards. So it's thrown out repeatedly in these loops and copied one section at a time, creating two new DNA molecules. Now, you have billions of this machine right now whirring away inside you, copying your DNA with exquisite fidelity. It's an accurate representation, and it's pretty much at the correct speed for what is occurring inside you. But I've left out error correction and a bunch of other things. This was work from a number of years ago. Thank you. This is work from a number of years ago, but what I want to show you next is updated science. It's updated technology. So again, we begin with DNA, and it's jiggling and wiggling there because of the surrounding supermolecules, which I've stripped away so you can see something. DNA is about 2 nanometers across, which is really quite tiny. But in each one of your cells, each strand of DNA is about 30 to 40 million nanometers long. So to keep the DNA organized, to regulate access to the genetic code, it's wrapped around these purple proteins. I've labeled them purple here. It's packaged up and bundled up. All of this field of view is a single strand of DNA. This huge package of DNA is called a chromosome, and we'll come back to chromosomes in a minute. We're pulling out, we're zooming out through a nuclear pore, which is sort of the gateway to this compartment that holds all the DNA called the nucleus. All of this field of view is about a semester's worth of biology, and I've got 7 minutes, so we're not going to be able to do that today. No, I'm being told no. This is the way a living cell looks down a light microscope, and it's been filmed under time-lapse, which is why you can see it moving. The nuclear envelope breaks down. These sausage-shaped things are the chromosomes, and we'll focus on them. They go through this very striking motion that is focused on these little red spots. When the cell feels it's ready to go, it rips apart the chromosome. One set of DNA goes to one side, the other side gets the other set of DNA, identical copies of DNA, and then the cell splits down the middle. And again, you have billions of cells undergoing this process right now inside of you. Now we're going to rewind and just focus on the chromosomes and look at its structure and describe it. So again, here we are at that equator moment. The chromosomes line up, and if we isolate just one chromosome, we're going to pull it out and have a look at its structure. So this is one of the biggest molecular structures that you have, at least as far as we've discovered so far, inside of us. So this is a single chromosome, and you have 2 strands of DNA in each chromosome. One is bundled up into one sausage, the other strand is bundled up into the other sausage. These things that look like whiskers that are sticking out from either side are the dynamic scaffolding of the cell. They're called microtubules, but the name's not so important. But what we're going to focus on is this red region. I've labeled it red here, and it's the interface between the dynamic scaffolding and the chromosomes. It is obviously central to the movement of the chromosomes. We have no idea really, as to how it's achieving that movement. We've been studying this thing called the kinetochore for over 100 years with intense study, and we're still just beginning to discover what it's all about. It is made up of about...
Okay. When the first video showed the DNA replication going on, okay, there's a whole lot more going on than what you visually saw there. Another big thing that occurs is as soon as the DNA is made from both sides, you have a error detecting machine, okay? An error detecting machine. Okay, now how complex it is, I don't know, but it's probably pretty complicated. Okay, and what it does, it goes down the DNA and makes sure everything is right, because when DNA is copied, a lot of times there's a mistake that's made, and that error detecting machine will catch it, and it reports to another machine. It's called the error correcting machine, and then you have that machine attached to the DNA, and it goes along and corrects it. And it all came about by time and chance, right?
200 different types of proteins, thousands of proteins in total. It is a signal broadcasting system. It broadcasts through chemical signals, telling the rest of the cell when it's ready, when it feels that everything is aligned and ready to go for the separation of the chromosomes. It is able to couple onto the growing and shrinking microtubules. It's transiently, it's involved with the growing of the microtubules, and it's able to transiently couple onto them. It's also a tension sensing system. It's able to feel when the cell is ready, when the chromosome is correctly positioned. It's turning green here because it feels that everything is just right. And you'll see that there's one little last bit that's still remaining red. And it's walked away down the microtubules. That is the signal broadcasting system sending out the stop signal, and it's walked away. I mean, it's that mechanical. It's molecular clockwork. This is how you work at the molecular scale. So with a little bit of molecular eye candy, we've got kinesins, which are the orange ones. They're little molecular courier molecules walking one way. And here are the dynein. They're carrying that broadcasting system, and they've got their long legs so they can step around obstacles and so on. So again, this is all...
Okay, he calls them molecular molecules, and I call them molecular machines. Because molecules doesn't quite sound so, creative. Sounds like the molecules, they just walk down, walk on the microtubules and get from one place to another. So I think a better explanation, they're very complex machines and living things, and the more scientists learn, the more many of them are realizing it just couldn't happen. Okay, we're going to start the rest of that where we left off on the question of origins.
Both evolution and creation scientists have observed and agree that there is great variety within each species. Darwin noticed this variety and adaptability among finches. He noticed that the finches' beaks varied in size and shape, and that the beak's features affected the survivability of the finch. Today we notice a great variety of dogs. It is believed that all 450 breeds of dogs present today had a common ancestor. Most scientists believe that this ancestor was very similar to the present-day wolf. Scientists also witness natural selection, or survival of the fittest. Evolutionists and creationists agree that those animals that are the strongest, healthiest, or most adaptive to their environment, are more likely to survive and go on to reproduce. The weaker animals, which are unable to adapt, are less likely to survive. We also observe gene mutations occurring. The DNA in all living organisms contains all the genetic information of life. Sometimes an error is introduced in this genetic code. This is called a mutation. Mutations often cause disease and can be induced by radiation, chemical agents, or replication errors.
Mutations really do occur. They make all kinds of changes in genes. Birth defects, disease organisms, they're great at explaining the origin of disease, death, and disaster, not at all at explaining the origin of something new, some new trait that never exists. All the mutations we know about are only changes in genes that already exist.
Darwin observed many things in nature. He was a good naturalist, a good observer of information. What he saw was various plants and animals altering somewhat through adaptation, through variation. He saw them change. We never see one basic type of something changing into something else. That has never been observed in science or in genetics. It just has never been observed. What we see is variety. Variety happens, adaptation happens, evolution doesn't happen.
Mutations, natural selection, adaptation. These are some of the observations that both evolutionists and creationists agree upon. But in spite of the agreements, there are substantial differences. And so the debate rages on.
I mean, you have such a wide variety of life, and I don't think it's possible for one person. I mean, no matter how powerful he might be, to just snap his fingers and create life. It has to come out naturally over millions of years, probably.
I don't believe in the theory of evolution. More and more, even secular scientists are changing their viewpoints because the evidence doesn't support their conclusions.
Half of me believes in the theory of evolution, probably because that's what I was taught.
4 years of studies, unfortunately, have kind of brainwashed me towards evolution.
We begin where evolutionists say it all began, with the Big Bang and the evolution of the universe.
One interesting aspect of evolutionary theory is that it's such a powerful theory, and it exercises such a strong hold over the imaginations of scientists that they've applied it outside the biological realm. They've applied it to inanimate things as well. They've applied it to the chemical elements, to stars, to galaxies. It's said that the universe itself is evolving.
Did the Big Bang trigger the formation of galaxies, stars, planets, and ultimately life?
Is there any order coming out of a big explosion? I would say not in any way. Explosions cause chaos and random distribution of various parts that were there perhaps as a united organisation beforehand. Any explosion renders that completely null and void. There is no evidence to my mind that an explosion or even the Big Bang Theory can ultimately produce organised beings like ourselves or any other animal.
Evolutionary thinking is applied to most areas of science. The field of evolutionary cosmology proposes that the universe is the result of a random explosion some 15 to 18 billion years ago. There are no examples that I've ever seen where an explosion produced an increase in order. Explosions are destructive. They cause spontaneous degeneration, not spontaneous generation.
Scientists recognize that all known explosions decrease order and structure and increase chaos. The idea that the cosmos evolved also violates the second law of thermodynamics known as entropy. The second law states that as time advances, the universe becomes less ordered. Over time, all systems left on their own proceed in a direction from order to disorder. All of us witness entropy every day as we see things age and deteriorate. This breakdown of structure directly contradicts the theory of evolution.
Now, the second law allows you to increase in order, like a baby growing into adulthood or seed into a tree, but if and only if you have an outside energy source and a harnessing mechanism to capture that energy. Evolutionists don't have that. As Sagan said, the cosmos is all there ain't no more. There is no outside energy source. So the second law is absolutely contradictory to the Big Bang theory.
What we see in cosmology is this. Everything we see, things are running down. Stars are burning up their fuel. Once in a while, a star will explode and goes from order to disorder very quickly. But the only thing we see in the universe today is the universe is running down. It's deteriorating. It's going from order to disorder. It's going to less and less organization.
There is an observation that scientists make in every field of science, and it's generally called the laws of entropy. It's as if the universe was wound up somehow and is winding down. Scientists that study cosmology talk about the ultimate heat death of the universe. Conceptually, it's quite clear from what we know that the universe ultimately sometime billions of years from now, everything will become of uniform temperatures. There'll be no difference in temperature to exploit to get useful work.
That the universe had to be designed and ordered in the finite past has not escaped the attention of secular scientists. NASA scientist Robert Jastrow wrote, "The second law of thermodynamics applied to the cosmos indicates the universe is running down like a clock. If it is running down, there must have been a time when it was fully wound up. The next obvious question is, who wound it up?" Gordon Van Wylen addressed the question squarely in his book Thermodynamics when he wrote, "The author has found that the second law tends to increase his conviction that there is a creator who has the answer for the future destiny of man and the universe."
We only see destruction, we never see innovation. And this, I think, is what the creationist model has been proposing all along, that in the beginning things were very good, they were perfect, just like God wanted. But then, as sin entered into the universe and God's curse on all of creation because of that sin, the wages of sin is death, not only in the physical life, but in the universe, everything is dying. The sun is burning out, the moon's orbit is decaying, everything is in this process of death and decay.
Evolutionists and creationists agree now that the universe is finite. Space and time and matter had a beginning. Beginning with the studies of Albert Einstein in the early 1900s on through this century, scientists are in agreement that space, time, and matter did indeed have a beginning.
20th century science, embarrassingly, has confirmed the biblical view, because the great discovery in cosmology is that the experts have agreed that the universe had a beginning, and they call it a singularity. You see, the whole Big Bang idea really is, first there was nothing, and then it exploded. The fact that the universe is finite, that it had a start, is a key fact, but a very, very awkward fact for the evolutionist, because it really raises an issue they won't deal with, and that is what happened prior to that singularity.
The creation model has always anticipated a finite universe. In the first verse of Genesis, we read, "In the beginning, God created the heavens and the earth." The Bible also states that time had a beginning. In 2 Timothy, we read, "God, who has saved us and called us with a holy calling, not according to our works, but according to his own purpose and grace, which was given to us in Christ Jesus before time began." Amazingly, the Bible even explains entropy. "Of old, you laid the foundation of the earth, and the heavens are the work of your hands. They will perish, but you will endure. Yes, they will all grow old like a garment." If the universe did not originate from an explosion, the only other option is that it was created, an option that many scientists are not willing to consider.
almost all scientists would try to find a mechanical explanation of how the stars, the galaxies and the planetary system came into existence by purely mechanical means without any intervention of a God in creation. To my mind, they have utterly failed. If you look at the planetary system alone, there have been several explanations trying to show how the planetary system came into existence without any pre-formation by God, and each one has failed miserably.
Many observations contradict the current theories on how the solar system evolved. The most popular theory holds that the solar system formed from an interstellar cloud of swirling gas and dust. If the sun, planets, and moons evolved from the same material, they should have many similarities. Yet each planet is unique. Since about 98% of the sun is hydrogen or helium, Earth, Mars, Venus, and Mercury should have similar compositions. Instead, much less than 1% of these planets is hydrogen or helium. If the solar system evolved, all planets should spin in the same direction. But Pluto and Venus rotate backwards, while Uranus is tipped on its side and rotates like a wheel. All moons in our solar system should orbit their planets in the same sense. But at least 6 have backward orbits. Furthermore, Neptune, Saturn, and Jupiter have moons orbiting in both directions. Growing a planet by many small collisions will produce an almost non-spinning planet, since the impacts will be largely self-canceling. Yet, all planets spin, some much more than others. Growing a large, distant, gaseous planet such as Jupiter or Saturn poses an insurmountable hurdle for evolutionists, because gases dissipate rapidly in the vacuum of outer space. And even young stars, similar to our Sun, do not have enough orbiting hydrogen or helium to form even one Jupiter. Scientists have no answer as to why 4 planets have rings, or why each planet is so unique. Theories on the moon's origin are also completely inadequate. The moon's elements are too dissimilar to those of Earth's, and its orbital plane and circular orbit offer strong evidence that the moon was created in its present orbit.
There is no evidence that the planetary system could have come about by mechanical means. However, the more that scientists began to look at the amazing universe that they inhabited, they began to realize that there were certain factors that were simply very, very fine-tuned for the existence of man, of molecules, of organic life. And the more they looked, the more they realized that we are in effect on really quite a knife edge, and there are many, many indications that this universe has been very specially designed and man is at the very center of it.
If we try to model the universe as we know it, as we try to build a mathematical model that reflects what we know, we quickly discover there are thousands of parameters and ratios that if you adjust them even a little bit, life is impossible. We quickly discover that the Earth was a little closer, a little further from the sun. It's either too warm or too cold. If it turns at a little different speed, if the masses are a little different, it would hold too much or too little atmosphere. As you start trying to model this, you quickly discover that all the parameters involve an incredibly delicate balance. And so they call this the anthropic principle, meaning it's as if everything we know was skillfully designed or balanced for man.
The Earth is at a very specific distance from the sun, and they have calculated that if we were only 5% closer, the water would boil off from the oceans. If we were just 1% further away, then the oceans would freeze. And that gives you just some idea of what sort of a knife edge we are on.
The surface gravity of the Earth is exactly where it needs to be. More, you have too much atmospheric pressure, less, you don't have an atmosphere. The thickness of the crust is critical, the rotation period of the Earth, the gravitational interaction between the moon, strangely enough, all these contribute to what makes life possible. And so they call that the anthropic principle, which collectively is an overwhelming argument for a designer. Scientists don't like to acknowledge that because a designer implies accountability.
That the earth was fine-tuned for the existence of life is no surprise to creation scientists. The Bible declared this fact thousands of years ago. In Isaiah we read, "For thus says the Lord, who created the heavens, who is God, who formed the earth and made it, who has established it, who did not create it in vain, who formed it to be inhabited." Physicist and Nobel laureate Arno Penzias stated in 1992, "Astronomy leads us to a unique event, a universe which was created out of nothing, one with the very delicate balance needed to provide exactly the right conditions required to permit life, and one which has an underlying, one might say, supernatural plan." Astronomer George Greenstein stated in his book, The Symbiotic Universe, "As we survey all the evidence, the thought insistently arises that some supernatural agency must be involved. Is it possible that suddenly, without intending to, we have stumbled upon scientific proof of the existence of a supreme being? Was it God who stepped in and so providentially crafted the cosmos for our benefit?" The more we study the cosmos, the more the psalmist's words ring true. "The heavens declare the glory of God, and the firmament shows his handiwork. Day unto day utters speech, and night unto night reveals knowledge. There is no speech nor language where their voice is not heard."
For me to believe that all our life and our planets came from one big bang, I don't believe it. I believe there is a higher power out there.
No, I do not believe that the universe has some sort of maker behind it.
Well, I believe the universe started with the Big Bang.
I believe the Earth was designed for life because everything we see around us, everything we need to live, everything we need to survive and be happy is all around us. We don't want for anything. All our food, our air, everything to make us happy and for us to survive is here. So there had to be an originator of this. It couldn't have just happened by chance.
The evidence clearly reveals that God has created the universe and the solar system and specifically designed the Earth for life. Yet many would rather trust and believe in the Big Bang rather than trust and believe in the God of the Bible. In the next section, we'll examine the possibility of life arising from chemicals spontaneously.
Did chemical evolution on the primordial Earth produce life? According to evolutionary thought, all life, bacteria, fish, plants, animals, and man, originated from chemical compounds. This theory that life arose from non-living chemicals is called spontaneous generation.
One of the fundamental laws of biology is the law of biogenesis, that life comes only from pre-existing life. And of course, for a creationist, that's certainly no surprise. Life, God's life, created life to multiply after its kind. So that makes sense to a creationist. But to an evolutionist, there was a time in the past when there wasn't any life. And so chemicals somehow got together and made living things, and this was often called spontaneous generation. And there have been some enormous problems faced in trying to get a group of chemicals to come to life. A few years ago, Stanley Miller did a famous experiment. He took some simple materials, some methane, some ammonia, some water vapor, zotzed them with an electric spark to simulate lightning flashing back and forth in the atmosphere of the ancient Earth, and in just a week, he got amino acids, the building blocks of protein. And that was hailed as almost making life in a test tube. And that was one I used when I used to teach evolution. But I took a look at the rest of the evidence. And there are three problems with that brilliant experiment. One, he had the wrong starting materials. Two, he used the wrong conditions. And three, he got the wrong results. Other than that, it was a brilliant experiment.
The Miller experiment assumed an atmosphere of methane and ammonia, gases that could not have been present in large amounts because the ammonia would be decomposed by ultraviolet light, and methane should be found stuck to ancient sedimentary clays, but is not. Miller also left out oxygen because he knew that oxygen would destroy the very molecules he was trying to produce. But as deep as we dig, we find oxidized rocks, suggesting an oxygen-rich atmosphere.
The Earth did not have a reducing atmosphere, say an atmosphere of methane, ammonia, and hydrogen that was suggested in the Stanley Miller experiment. The Earth never had such an atmosphere. The geology is now clear. There is good evidence that the Earth has always had oxygen in its atmosphere. Now that would absolutely preclude any evolutionary origin of life.
Miller also used the wrong conditions. He used an electric spark to combine the gas molecules. The problem is that the same spark that puts amino acids together also tears them apart, and it's much better at destroying them than making them.
The problem was the chemicals put together, the amino acids in the flask, would also be torn apart by the very spark that put them together. Miller knew that as a biochemist, and so he circulated the gases, trapped out the molecules he wanted using a well-known biochemist trick, but that would be cheating, because you were supposed to say this is how life arose before there was any intelligent design to preserve these molecules from that destructive force. Wrong conditions. Then he got the wrong results.
The main product of the Miller experiment was tar, a nuisance in organic reactions. Trace amounts of several amino acids that make up the proteins in living things were also produced. The problem is that Miller's experiment produced both left-handed and right-handed amino acids. Only left-handed amino acids make up the proteins of life, and just one right-handed molecule prevents their production. What Miller actually produced was a poisonous brew that would destroy any hope for the chemical evolution of life.
You might say, well, if what I've just said is true, what about all the evolutionists that believe in this? Well, interestingly enough, the evolutionists would agree with me. There was a time I was at a debate at San Diego State University. I was just in the audience, but two friends of mine, Dr. Henry Morris and Dr. Dwayne Gish, were doing the debate for the creationists, and at the end, someone in the audience noted, "Ladies and gentlemen, we're privileged this evening. We have in our audience Dr. Stanley Miller." And Gish had explained why Miller's experiment would not produce life from non-life. And so the person asked Dr. Miller, "Would you like to respond to what Dr. Gish said about your experiments for chemical evolution?" And Dr. Miller said, "No." He hasn't believed in that for decades. He knows all of those same problems.
I would say this: any theory on the origin of life on the Earth, or any other planet as far as that's concerned, is a fairy tale.
Evolution teaches that energy, such as lightning or heat, plus matter, can occasionally create new life. Yet our entire food industry rests on the fact that this can never happen. If we examine a jar of peanut butter, it contains matter and is exposed to light and heat. But we never find new life inside unless an outside life contaminates it.
If the theory of evolution was viable, then I should occasionally, by subjecting this to energy, end up having new life. Now we go down to the store, and if I open this jar of peanut butter, maybe not often, but on some occasion, I should find new life inside. And so when we open the jar of peanut butter, we look in there, there's no new life. And aren't you glad, okay? Now, you may smile at this, but hopefully you'll never forget it, because you and I conduct, collectively, over 1 billion experiments every year, and we've done that for virtually 100 years. And we never encounter new life. In fact, the entire food industry of the world depends on the fact that evolution doesn't happen.
The case for chemical evolution only weakens when we consider that long chains of specific amino acids, all in exactly the right position, are required to form the proteins of life. Even worse, amino acids do not naturally link up to form proteins, but rather tend to break down.
Now, proteins can be 2,000 or 3,000 amino acids long, very long, complex chemicals. And they're very much like a computer program. Every amino acid has to be in exactly the right position. If one of them is wrong, then the whole protein is useless, just like a computer program.
The improbabilities buried in Darwinism start right at the very beginning, even before life began. How did the first protein molecule come about? And there's been quite a bit of work done on this to investigate the probability of it, work both by information theory technologists and also by molecular biologists actually tinkering with proteins to see whether or not they can be taken to pieces and reassembled. And the work of both groups has found that the probability of a protein of the sort of size that you find in the human body coming about by chance is so great as to be virtually impossible. It's something which is, yes, it is possible if you have eternity at your disposal, but Darwinists just don't have eternity at their disposal.
Information theory scientist Hubert Yockey calculated, and MIT biologist Robert Sauer confirmed, that the probability that a protein containing just 100 amino acids would form spontaneously is less than 1 chance in 10 to the 65th power. An event so improbable that it could be compared to winning the state lottery by finding the winning ticket in the street, and then continuing to find the winning ticket in the street every week for 1,000 years.
The origin of the very first animal life out of ordinary complex chemicals is so large that no evolutionist has ever been able to overcome it, and it is one of the biggest barriers to the theory of evolution that I know.
Even if proteins miraculously formed, we still are not close to producing life. The simplest living cells require thousands of specialized proteins in order to function.
A number of scientists have tried to calculate the probability of life arising by chance. Sir Fred Hoyle, a British mathematician, using a supercomputer and the assistance of graduate students, estimated only the origin of the proteins of an amoeba, 2,000 of them, arising by chance. He estimated that the probability that the proteins of an amoeba could arise by chance is 1 chance in 10 to the 40,000th power.
A probability of 1 chance in 10 to the 40,000th power is absurdly small. To illustrate this, consider the probability of snatching a particular atom out of the entire universe.
Can you hear me? Okay, we're going to stop there. It's almost 8 o'clock. I just want to tell you a little story, and it was one of the highlights. We took a mission, Luann and I took a mission trip to Albania, and the last few days we were there, we were kind of on our own, and we were walking around Tirana, and we ran into this guy, and he was a tour guide, and he was a historian. That was his major in college, and so he, I won't tell a long story, but anyway, we got acquainted with him. It's kind of a long story. And so he was going to, since he couldn't find the people he was supposed to take on the tour, he took us on a tour, and he wasn't going to charge us. So we were walking around the city and showing all this stuff. Well, before too long, we went into a little place and got something to eat or a little drink, and it came out that one thing led to another, and the guy said he was an atheist. And I go, yeah. So basically, I started witnessing to him, and one little thing that just blew his mind, and I'm sure it was more than just one thing, but I could see as I talked to him and witnessed to him, explained to him why there has to be a creator, there has to be a God, is he could look at him. He got to the point where he just didn't even want to look at me, and he could tell I shattered his worldview because it's not based on anything that's true. And so anyway, another thing that I did, this would be good. If you take a deck of cards and you take it out, it's a new deck, and you take the deck of cards out of the package. Okay, is it in a certain order? How many of you know that? It's not random order when you take it out, is it? it's probably the first, you know, hearts are first, ace through 2, and then spades, ace to 2, and so on, okay? And they're in that order. Okay, here's my question. What are the chances once you shuffle that deck a couple times that you could shuffle that deck for the rest of your life? Matter of fact, probably everybody on earth could shuffle the decks for the rest of their life. Is it possible that randomly that deck of cards is going to go back in the same order it was when you got it? The chances are 1 times 10 to the 54th power. The number like that, scientists say, it ain't going to happen. It's never going to happen. Okay, well, think about a protein that he talked about. Proteins are a whole lot more complex than a deck of cards being all in the right order. And so, you know, when you share somebody about the proteins and linking together just randomly by accident and producing a complex structure molecule that has a function, you know, the chance of that happening, it's not going to happen. So I'm just blown away. We have all the evidence. We have the laws are on our side. The laws of probability are on our side. So we need to start telling people that, you know, and we need to be witnesses to those unbelievers out there because they've bought into a big old lie here, you know, massive lie, and they don't understand it and they don't know why. You know, they can't figure it out. They're only told one side over and over and over and over and over and over and over, and they never told the other side. So your homework assignment this week is to go home and watch the rest of that video, okay? It's called A Question of Origins. And if you've got any people around the house, you know, it'd be good for them to sit down and watch it too. It's really good. It's old, you know, the animation there wasn't near as good. You know, it looks real simple, and when it looks at the proteins, they just look like a piece of rope. But anyway, it's a really good video. So appreciate y'all coming out. God bless y'all.